All right, hi everyone. So in this video, we are going to be learning all about empirical and molecular formula. So up until now, we have been learning about moles and Avogadro's number and molar mass, and we're gonna kind of take that and shift a little bit. So the first thing that we want to discuss is, what is an empirical formula? What is a molecular formula? And so what I want you to do is I want you to look to the right and I want you to look at this picture here, okay? And I want you to answer these three questions. 1, what is the chemical formula for this compound? 2, if you had to break it into equal segments or parts, how would you do it? And I want you to circle those segments on the picture. And then number 3, I want you to write the formula for the segment you created in number 2. So go ahead and press pause on the video, answer those 3 questions, and then we'll come back to discuss it. Okay, so for this chemical formula, we see that there are 2 nitrogens and there are 4 oxygens. Okay, so we have N2O4. Now, if we had to break this into equal segments, right, or equal parts, symmetrical parts, we can see that there's a segment here, and it's separated from this one, right, or it's equal to that one, 1 nitrogen and 2 oxygens. And so the formula for that would be N1O2. Now, what you just created was your molecular and empirical formula. So our definitions, which empirical formula can be abbreviated as EF, and molecular formula can be abbreviated as MF. An empirical formula is the simplified or reduced segment of a molecular formula, which I'm just going to abbreviate as MF. So we can see that the NO2, that's our empirical formula because that chemical formula has been simplified, and so we can look at its subscripts for that. The molecular formula is just the actual formula. So in this problem, that would be the N2O4 would have been your molecular formula because that's actually the formula that we have in this picture, and we can see that the empirical formula is repeated 2 times. Now, sometimes the empirical formula and the molecular formula can be the same. So, for example, if you were to have if you were to look at a molecule of carbon dioxide or even a molecule of water, H2O, you would notice that there was no way to split this evenly because if you put oxygen and hydrogen there, that would leave this hydrogen by itself. Or if you put this carbon and oxygen together, you would need that carbon for the other one as well. So there's no way to split those, and so the molecular formula would be carbon dioxide. And you also see that we have subscripts 1 and 2. You can't simplify that any further. So the empirical formula would also be carbon dioxide, CO2. Same goes for water. Now, go ahead and take a look at these practice problems. So what is the empirical formula of the following compounds? So how do you simplify or reduce these? So for example, we can see if we look at B, 10 and 22 can be simplified or reduced by dividing by 2, and that would give you C5H11. So we have our molecular formula, and the empirical formula is the simplified or reduced one. Go ahead and pause the video and complete practice problems A, C, and D. Okay, now that you've done those practice problems, and I'm not going to give you the answers in this video, you can come check them with me in class. Let's move on to part 2. What if you have your empirical formula and you want to determine what the molecular formula is? Okay, so we have this formula here. So it tells us that our molecular formula is equal to our empirical formula times N. And the way you figure out what N is, and that's really just your greatest common factor, okay? Because notice here, when you were simplifying, for example, to go from N2O4 to get NO2, you divide it by 2, which is your greatest common factor. Or for B, to get to C5H11, we also divided by 2, and that was the greatest common factor. We use that same thing, but where you would multiply by our greatest common factor, and to figure that out, you divide the molar mass of your molecular formula by the molar mass of your empirical formula. So if we take a look at our example, what is the molecular formula of a compound with an empirical formula of CH? So the empirical formula is CH, and the molecular formula has a molar mass of 78.11 grams per mole. Okay, so here are the things that we know. We know that our empirical formula is CH, and we know that the molar mass of our molecular formula is equal to 78.11 grams per mole. Well, we know that if I want to find out the molecular formula, because the question is, what is the molecular formula? That's what we're trying to figure out. We know that our molecular formula is equal to our empirical formula times N. And N is our molar mass of our molecular formula divided by the molar mass of our empirical formula. We have the first one. We don't have the second. So what we need to do is figure out its molar mass. So we use our periodic table, and we learned how to do this in our molar mass lesson. So we have carbon and hydrogen, and there's just one of each. So we multiply by their mass on the periodic table, so 12.01, 1.01, and then we add them together. So you get 13.02 grams per mole. And so we know that if I want to calculate N would be equal to the molar mass of my molecular formula, so 78.11 grams per mole, divided by the molar mass of our empirical formula, 13.02 grams per mole. And when you put that in your calculator, remember the 78.11, which is in your numerator, goes in your calculator first. You'll get 5.999, which is just going to be 6. Okay? And so this means to figure out our empirical formula, or our molecular formula, we'd say, okay, it's the empirical formula, so CH times N, which is 6. So that means our subscripts, which are invisible ones, we're going to multiply both of them by 6. So that means our answer is C6H6 as our molecular formula. So what I want you to do is go ahead and pause the video if you haven't finished getting your example down. And I want you to do number 1 and number 2 as practice. Use this as an example, and when you press play after you're done practicing, I will show you the answer, but not how we get the answer. Okay, if you need help figuring out if you've made a mistake, then come see me in class or at tutoring. Okay, now that you've done the practice, for number 1, you should have gotten P4O10, or tetraphosphorus decaoxide. And then for number 2, you should have gotten O3C3N3Cl3, which I'm not even going to attempt to name. So that is the second type. So part 1 was, we know how to figure out our empirical formula by just simplifying the molecular formula. We also know how to now figure out the molecular formula if we are told what the empirical formula is and we're given the molar mass. And then the third thing is that we can determine what our empirical formula is if we're given the breakdown of our percentages. So when scientists analyze compounds, so for example, maybe they're a forensic scientist and there's been a crime scene and they want to analyze a compound, they run it through a machine that is called a gas chromatography mass spectrometer, or GCMS. And if you've ever watched shows like CSI or NCIS, their forensic scientists typically mention this machine. But what it does is it gives a list of the elements that are in the compound and the amount of each chemical element as a percentage. So it'll say it's got 20% of the chemical is carbon and 15% is nitrogen, and it just lists it out. And using this information, we're able to turn those percentages into subscripts, because the subscripts are just ratios of each chemical to each other. And there is a handy poem that we can use to help us remember the steps of this problem. Okay, so percent to grams, that's step number 1. Okay, grams to moles, that's step number 2. Divide by small, step number 3, and multiply to whole, that's step number 4. Okay, so these are the 4 steps to finding your empirical formula when you're given the percentages. Okay, so if we look at an example of this, you might notice that in the video, the example changed from what was there to what this is now and what you should see on your paper. That's because I realized there was a huge mistake in that first example problem, and I wanted to fix it before we did this video. So our example says that a major textile dye manufacturer, so a company that produces dyes for fabrics, developed a new yellow dye. The dye has a percent composition of 75.95% carbon, 17.72% nitrogen, and 6.33% hydrogen by mass. And they want to know what is the empirical formula. Now we're going to use our poem to help us, and we're also going to color code each thing. So for step number 1, I'm going to do that in green. So the first thing we do is we change all our percentages to grams. So that means we literally change, so our 75.95% carbon, we're going to change it to grams by literally just swapping the percent sign and changing percent to a G for grams, because we're going to assume that we have 100 grams of this sample, and 75.95% of 100 grams is 75.95. Okay, so we're making an assumption there. We'll then do that for all of the other ones as well. So 17.72% nitrogen will be 17.72 grams of nitrogen. And then the third thing, or the third element, is 6.33% hydrogen will become 6.33 grams of hydrogen. Now notice I'm leaving a decent amount of space between each chemical because we are going to be putting work there in the future. So please make sure you space it out similar to how I have it on the screen. Okay, so that was step number 1. Step number 2, we're going to do in pink. Okay, so step number 2, we change grams to moles. Now remember, the way we change from grams to moles is by using our molar mass. And since these are each individual elements, we pull our molar mass from our periodic table. And if we have grams of carbon at the top, grams of carbon must go at the bottom. So we look at our periodic table and we know that 12.01 grams of carbon is equal to 1 mole of carbon. So grams cancel out with grams, and when we divide by 12.01 and multiply by 1, you get that there are 6 and you're going to want to keep 3 numbers after the decimal here. So 6.324 moles of carbon. So we're going to, again, repeat that for each element. So each step is not hard. The thing that is difficult is remembering that you have to do each step for all 3 elements. So for this, instead of 12.01, we'll have 14.01 grams of nitrogen is equal to 1 mole of nitrogen. And when we divide that, it gives us 1.265 moles of nitrogen. And we can change our 6.33 grams of hydrogen to moles by dividing by its molar mass, which is 1.01. And when we do that, 6.33 divided by 1.01 is 6.267 moles of hydrogen. Okay, so now that we've done step 2, our third step, which we're going to do in blue, so step number 3, is to divide by small. So literally you pick which of these 3 was the smallest answer, and that's what you divide by. In this case, 1.265 was the smallest amount. So each of these numbers, we're going to divide by 1.265 moles. Now, when we do this, let's do the carbon first. So 6.324 divided by 1.265 gives us, moles cancel out, so we get 4.999 carbons, okay? Moles cancels out here, and so that will give us exactly 1.0 nitrogens. Moles cancels out here, and 6.267 divided by 1.265 will give us 4.954 hydrogens. Now, for step number 4, which is multiply till whole, we're going to do that in red. Now, here's the thing that you have to be aware of. The multiply till whole, this is only if your number is not already really, really close. So if you're really close to a whole number, then you can just round. But if you see that your answer is, for example, if it was 4.5, we would need to multiply by all of our answers by 2 in order to turn that into a whole number. Or if you saw something that ended in 0.3 or 0.6, you would need to multiply by 3 in order to get it to a whole number. In this case, 4.999, 1.00, 4.954, those are all extremely close to being whole numbers, if not already. So for this, we're just going to round to 5, round to 1, and round to 5. And what this tells us is that our final answer has 5 carbons, 1 nitrogen, and 5 hydrogens. So the way we would write that, though, as our chemical formula, would be C5N1H5. And this would be our final answer. Okay, so that is how you do this type of problem. Okay, so again, follow your steps. Each step is not difficult in and of itself. It's just remembering the steps, the order they go in, and that you have to do it for each chemical. I'm aware that this is a lot of work, but hopefully with practice, you'll be able to get the hang of it. And speaking of practice, you have a practice problem right here. So why don't you pause the video, go ahead and get started, and then I can show you the answer when you're ready to press play. All right, so if you've pressed play, that means you're finished with the practice, and this is the answer that you should get. Most likely, if you made a mistake, you should note that in the last step of carbon, you should have gotten, after you divided by small, that there was like 2.459 carbons. And because this, right, if you were to round that to just 2 decimals, that would be 2.5. That means you need to multiply it by 2 for that to become a whole number. But that would mean you also, if you multiply carbon by 2, you have to multiply hydrogen and oxygen by 2 to get that whole number. Because you probably would have had like 4 and 1 here. Just make sure that you multiply all of them by 2. So if you need some more help with this, remember tutoring or ask questions in class. And good luck.